We know that we can solve similarity type problems using three methods. But I want to introduce you to the idea of looking at it in a proportion setup. Really what these are equivalent ratios. We've got a comparison of two like things and another comparison of two like things. Now to you, they might look like fractions, and that's okay. We can actually deal with them very similarly that we would with fractions, but in the back of our mind we always have to think of these as ratios or eventually proportions. We can solve them in the same three ways that we have learned. Crap, I gotta stop. We've only learned two ways. We can solve these using the two ways that we have already learned. Scale factors is one way. Remember, scale factors are comparing two similar things. So on a triangle, a base with a base, or a height with another height. In this case, we would compare a numerator with a numerator and a denominator with a denominator. For this specific problem, we know that there's a relationship. This 3 becomes a 1 by dividing by 3. That same divide by 3 happens when we do 12 to get to 4. Since they are the same scale factor, we know that this is a proportional setup, and we know that these are equivalent ratios. We can look at what we have considered equivalent ratios in a different way. And that's comparing our numerators with our denominators. So 3 compared to 12, well, that happens in a different way by multiplying by 4. The good thing though is if we look at our second ratio, 1 becomes 4 in the same way. In that sense, we can say that yes, in fact, these must be similar, these must be equal to each other because this equivalent ratio idea panned out. There's a third way though that we can double check ourselves, and that is by doing cross multiplication. What you do is you take your denominator of one ratio, multiply it by the numerator of the other, and then do it in the opposite direction. If we get the same answer for both of those cross multiplications, we know that we again have similarity, scale factors, equivalent ratios, and so on. In this case, 12 times 1, the denominator of 1 times the numerator of the other, gives us an answer of 12. In order to have similarity, that must mean the numerator of the other times the denominator has to be 12 again. And we know that, in fact, 3 times 4 does equal that same 12. We can use this idea to solve for unknown figures, or unknown values. We could look for a scale factor and say, how do we get from 5 to 10? Well, we multiply it by 2. Well, then 2 times 2 will give us our answer of 4. We could look for equivalent ratios and say, how do we get from 5 to 2? Well, in this case, we divide it by 2.5. If we divide 10 by 2.5, we'll get our same answer of 4. But it might have been quicker to look at the cross multiplications and say, well, 2 times 10 is 20. 5 times something must also equal 20. Well, we know that 5 times 4 will get us that 20. In all three instances, scale factors, equivalent ratios, or cross multiplication, we figure out that that unknown value must be 4.
Nonlinear inequalities, part 1.